Hello everyone, welcome back to the channel and today we are going to solve eat pizzas the problem. Okay, so here we are given n pizzas which is a multiple of 4 and we have to eat at least 4 pizzas every day and we have to find how much weight we can gain, how much maximum weight we can gain after eating 4 pizzas every day. Okay, so let's say each pizza has particular weight. So let's say we have 1, 2, 3 and 4 which is the weight of each pizza. Here, the condition says that if we are eating these whole pizzas in a day which is odd day, that means if we are eating it in day 1, day 3, day 5, and so on, then the weight which we will gain will be the highest weight of the pizza, any of these 4 pizza. Okay, so for that odd day, we will gain highest weight of pizza. Okay, so let's say if we are eating this whole 4 pizzas, then we will only gain the weight of this highest pizza, that is 4 here. Similarly, if we eat all these 4 pizzas in even day, then we would be increasing our weight, which would be similar to the second highest weight. So here, if we are eating it in even day, then the weight which we will be gaining would be second highest. So here we have to find in so here we have to find how much maximum weight we can gain by eating all the given pizzas. So for that, we have to eat these pizzas in specific order while making specific groups so that we can gain maximum weight each day. So let's understand this with examples. So let's say we have these pizzas 1, 2, 3, 4. So here we are already aware that the number of pizzas would be multiple of 4. So there can be these pizzas, or let's say 1, 2, 3, 4 until 8, or let's say 1, 2, 3, 4, 8 and until 12, let's say, and so on. So the size of this all pizzas would be multiple of 4x. Also, all the pizzas weight can be same as well. So let's say we can also have 3, 3, 3, and 3 as a size of the pizza. So let's see if we have these particular pizzas, how much maximum weight we can gain by eating these pizzas. So here it's simple. We can eat all these 4 pizzas in single day, and that would be 4 because 1 is odd number and the weight we will gain on odd number day would be the maximum of all the 4 pizzas. So for all these 4 pizzas, on first day, we will eat 1, 2, 3, 4, and we would be gaining 4 as a maximum weight. So maximum weight would be 4. What if we have 8 pizzas? Okay, so we have added this additional pizzas. So how much maximum weight we can gain? So do you think we can just follow the same approach? Let's say if we eat 1, 2, 3, 4 pizzas this day and remaining 5, 6, 7, 8 pizzas the next day, that would be second. But here, remember, as the day is even here, the weight we will be gaining would be the second highest. So the answer would be 7. So the total weight we gain will be 11. Do you think this is the maximum weight we can gain? What if we want to get the maximum weight? What if we choose these pizzas on first day and this pizza on a second day? Okay, so have you seen in this approach, we have missed this much weight by just including in our group of pizzas with the second day. So let's consider another approach. What if we eat our pizzas by this way? 1, 2, 3, and 8 on first day. Here, the maximum weight of this pizza would be 8. So weight which would be gaining would be 8 as well. What if we have here 4, 5, 6, and 7? So here we would be gaining the second highest maximum weight. That would be 6. So here we would be gaining 14, which is clearly greater than this 11, which was our first calculation. Okay. So there is clearly some way through which, or let's say there is clearly one way to eat these pizzas in particular order as well as making the group so that we can maximize our weight gain. So simple observation here would be if let's say this there is 8 pizzas, So we can eat this in 2 particular days, and we would be only gaining weight of 2 pizzas of any of the given day, as we have to finish this all 8 pizzas in 2 days. So we would be gaining maximum weight from 2 pizzas. And if we want to maximize the weight gain of ourselves by eating just only 2 pizzas, so that we have to select these 2 pizzas such that we can maximize our weight gain. So it's obvious that we would pick these 2 pizzas only. Why would we pick this or this? Or let's say this or this. Let's say this or this. No, right? We want to pick these 2 pizzas if we want to maximize the weight gain from all of these 8 pizzas. But is it possible to choose these 2 pizzas? Okay. So let's see if we can choose these 2 pizzas in our eating menu on 2 separate days such that we can maximize our weight gain. So for choosing this 8 pizza, let's include it in our menu. So let's say on first day, we will, for 2 day menu, the maximum weight we would be gaining from these 2 position. So remember, as this is our odd day and this is our even day, we have to pick the last, which is the highest weight of the pizzas on first day and the second highest weight of the pizzas on second day. So we want to maximize the weight gain. If we want to maximize the weight gain from these 2 particular pizzas, then we have to put these 2 pizzas in these particular positions. So we can put 8 here and we can put any of the pizzas here. 1, 2, 3, 2, 3, 4, 5, 6, 7. It doesn't matter, right? And right. On the second day, we want to put 7 here. So is it possible this way? So let's see. Here we can put 8. That is possible because every of every of these pizzas would have weight less than this 8 because 8 is the maximum. But what for 7? Is it possible to put 7 here? Let's see. Can we put 1 here? No, right? Because this is not the sorted order. 7 is obviously greater than 1. What would be the maximum value we can put here? We can put 6 here because that is only one which is left, right? But that is not greater than 7. So from this observation, we can say that it is not possible to put 7 here because we would be needing 7 here such that we can get the second max highest number in this particular position. So what if we are not able to put 7 here? If we are not putting 7 here, then the second highest pizza would be 6. So we can put 6 here as well because we can put 7 and 7 is always greater than 6. So the maximum weight we can gain by this two operation would be 14, 8 plus 6. And we can put arbitrary random pizza values in any of these 5 positions. It doesn't matter if you put 1, 2, 3, 4, 5, or let's say 1, 2, 1, 4, 5, 2, 3. It doesn't matter because anyways we are going to gain weight from these 2 positions only. What if we have 12 pizzas? 1, 2, 3, 4, 5, 6, 10, 11, 12. If we want to maximize the weight gain, so here we have to divide all these pizzas in 3 particular group of 4s. So that would be, let's say this, and this. So we have to form 3 groups. So we have to eat all these pizzas in 3 days. And we have 1, 2, 3, 4 position. 1, 2, 3, 4 position. 1, 2, 3, 4 position. The weights which we would be gaining from all these 4 position would be from here because this is our odd day and we would be gaining weight from our maximum position from here because this is even day and we would be gaining weight from our second highest position and from here because this is odd day. So if we want to maximize the weight gain from all of these pizzas, which pizzas should we pick? Obviously, we would pick the weights, the maximum weighted pizza. So let's put them all into this place. So 12, 11, and 10. So by this way, we can gain the maximum weight. But is it even possible to put this way? Let's see. Here, it's okay to put 12 because every element would be smaller than 12. in these three positions. What for this position? Is it possible to put 11 here? Is it any remained weight of pizza which is greater than 11? No, right? Because we have already used 10. We have already used 12. 10 would obviously not a choice because 10 is less than 11. And we have to keep this order sorted as we have already seen in this particular condition that the order of the pizzas should be sorted. And for odd day, we have to eat. We can gain maximum weight by the highest position, which would be the last position in this particular order. And for even day, we can gain the second highest position's weight. Okay, so it's clear that we cannot put 11 here because there is no other pizza which has weight greater than 11. Okay, so let's move it. So putting 11 in this particular position is not a choice. Can we put 11 here? Yes, we can because all the values after it would be lesser than it. So we can put 11 here. What if 10? We cannot put 10 here as well because now the 10 is the highest position of these used pizzas and we don't have any of the pizzas which has weight greater than 10. So we have to put all these pizzas. We have to put one pizza here. No one has greater than weight greater than 10. So 10 is obviously not the choice. So we have used 12, 11, but not 10. We can use 9 here. Can we use 9? Let's put it there. If we use 9, we can obviously make here, we can obviously put 10 here because 10 is greater than 9. And all the other values we can fill up by choosing all these remained pizzas. So it doesn't matter. But because we have to choose this, this, and this as our weight. So that would be 12, 9, 10, which would be equal to 31. This is the maximum weight which we can gain from this particular order. So notice the pattern here. Let's uh, consider the last example to conclude our approach of this algorithm. What if we have 1, 2, 3, 4, 8, 9, 10, 15, 16? What if we have this much of pizzas? We can clearly divide all this in four parts. So we have to consume all these pizzas in 44 particular days. 1, 2, 3, 4. Each has four positions. From each of these positions, the weight which we would be gaining from these positions only. So as this is our odd day, we would be gaining weight from the next position. That means the highest weighted pizza. For the even day, we would gain weight from the second highest weighted pizza. For third day, we would be gaining weight from the highest weighted pizza. And similarly for fourth, as this is a even position, we would gain weight from this particular position. Okay. So in order to maximize the weight gain, we can obviously pick these last four most weighted pizzas. Can we put them in this particular group and orders? Let's do that. What if we put 16 here? We can easily put 16 here because all the weights remain are clearly less than this 16. Can we put 15 here? No, we cannot because all the weight remained. No one from this remained pizza would have weight equal to 16 or later. That means greater than 15. So we cannot put 15 here. Can we put 15 here? Yes, we can. Because all the weights of pizzas after it will be clearly lesser than that. So 15 is also used. Can we put 14 here? I think we cannot because let's say if we have put 14 here, then we don't have any element to put here because any of the elements from this remained pizzas will have weights lesser than the 14. So as you have seen, we are decreasing our pizza size from 16, 15, but as soon as we have to put our pizzas in odd position, we cannot put the maximum available highest weight of pizzas. We have to put one lesser than that. So here we can put 13 so that we have 14 available here. We can put 14 here. Okay. So what for this last position? So last position we have already consumed 16, 15, 14, 13. So the last available highest weighted pizza is 12. Can we put 12 here? Obviously not. Because after putting 12, the available pizzas are only until 11. So we don't have any pizza to put in this particular position because the pizza which has this position should obviously greater than this 12. So we don't have any pizza weight which is greater than 12. So have you observed this pattern that for this position as well, we would be putting one less than the maximum available weight, that is 12, so that we can put 12 here and our condition would be satisfied. So the maximum weight here we can gain, that would be 16 plus 15 plus 13 plus 11. 16 plus 15, 13 plus 11. So the maximum weight we can gain by this particular order, that would be 55. Now have you noticed the pattern here? So in the first example, when we had 1, 2, 4. So in that particular position, the maximum weight which we gained was 4. That was the maximum value when we sort all the 4 pizzas. Okay. What for second? So in this approach, the maximum weight which we can gain was through 8 and 6. Okay. So 8 and 6. So this is the maximum value. And for even position, we have skipped this 7 and got another value, which is 6. What for third approach? So for third approach, we got maximum value as 12, 11, and we skipped one value, which is 10, and put 9 here. So 10, so this was a mistake here, 12, 11, and 9. So it would be 32. And what is for this scenario? So we gain 16, 15, we skipped 1 for even position and got 13. We skipped 1 for even position and got 11. Okay. So from this, we can say that for all the odd positions of this particular days, we can easily get the maximum available pizza. And for even positions, we will just skip one index and we'll get the max weighted pizza. We will skip just one index and we'll get the max available pizzas. So let's say if we have, so let's say we have 24 pizzas, each numbered from 1 to 24 weights. We will have 6 into 4. That means 6 days to finish it off. How much maximum weight we can gain? So from all the 6 days, let's number all the 6 days. For all the odd days, we can get the maximum available pizzas. So that means 24, 23, 22. But for this even position, we have to skip one pizza so that we can put it in the next position among those 4 positions. So we will skip 21 here and we will get 20. We will skip the maximum available, which is 19. We will skip that and put 18 here. So 18. We will skip the maximum available, which is 17 here, and get the 16 here. So for all odd position, we are continuously getting the maximum pizzas, and for even position, we are skipping one from maximum available pizzas. You will gain more depth. You will understand more this in the coding part. So let's move to the coding part. First, we have to sort all the pizzas so that we can iterate from the last position and get the maximum pizza to gain maximum weight. So let's first sort it. Pizzas dot sort. Let's initialize our size variable, which is equal to size of the pizzas. Okay. So now uh, let's initialize weight gain with 0. Then we have to determine the number of days, which would be equal to the size of the pizzas divided by 4. This would be equal to our number of days. So let's say if we have 8 pizzas, then we would have to complete them in 2 days. So 8 by 4, at 4, for each day we will eat 4 pizzas. So by that way, we can calculate the days. Then we have to figure out, let's say if we have 5 days, then we would have 1 as an odd day, 2 as an even day, 3 as odd, 4 as even, 5 as odd. So for 5 days, we have 3 odd days and 2 even days. Okay, what if for we have 4 days? So for 4 days, we would have 2 odd day and 2 even days. So for odd, so if we have number of days is equal to odd, then we will have n by 2 plus 1. That means n by 2. Here n by 2 in Python will simply become the base value, then n by 2, which means 2.5, but the base value would be 2, and we would increase 1, and that we will get 3. That means 3 odd days and n by 2 even days. What for even days? So for if we have number of days is equal to even, then we would have n by 2 is equal to odd, n by 2 odd days and n by 2 even days. Just if we have odd days, odd number of days, then we would have additional odd number of day. So we are doing here so that we can know how much time we can pick the maximum weighted pizza continuously. And for other even days, we will just skip one pizza of maximum weight and get the next available pizza. So from this, we will have n by 2 odd days and n by 2 even days. So keep this in mind for our next coding part. So if we have number of days is equal to even, then the odd count would be n by 2 plus, okay, odd count would be n by 2 and even count would be n by 2 as well. But if we have number of days is equal to even value, then we have odd values, odd count n by 2 plus 1, even count would be n by 2 only. Now we have to iterate through all the pizzas from the maximum position, that is index is equal to maximum available highest weighted pizza, that would be the last pizza. We have to pick all those pizzas until we place them in odd count. That means we eat max available weighted pizza, and we for even position we will pick second max available weighted pizzas. So for odd days, we will pick maximum available weighted pizza. So for that, while if our counter is, if we initialize our counter to calculate this odd number, and if it is less than odd count, that means we are going through all the odd days to pick the maximum available weighted pizza, and we will include it in our weight gain. We will decrease index by 1 and increase counter by 1. So from 0 to odd count, all days we will eat the pizzas with maximum available weight from the previous size, because see, we are sorting it. So from the rightmost position, we are iterating through this pizza list and we are including it in our weight gained. Similarly, let's initialize our counter to 0 again so that we can count our even days. We can pick pizzas for our even days. So for even days, if our counter is less than even count, we will include weight gained plus pizzas index. And here we are doing index minus 2 because we are skipping one index in between so that we can put it in our fourth position so that we can get maximum available pizza at third position. And we are increasing our counter value. And then we will just return the maximum weight gain. Here, there is one catch. As we have iterated, let's say if we have 1, 2, 3, 4, 5, 6. Here we have iterated through this position for our odd count. The next available index would be 7 if we are doing this way, but we want 6 to include in our weight gain because we want to skip this. So for first time, we have to minus 1 from this index, and for the next subsequent counts, this for loop will manage by removing one particular pizzas from each particular iteration, and we will be getting the next max available pizza. Okay, so I hope this is clear. Let's try to run it. Okay, so we missed 2 here, and we have to do 0. Okay, so there is one mistake. We have to divide days, not size. Let's do it again. Okay, so it's accepted. Let's run it. Okay, so as you can see, it's accepted. Let's go through the code again to understand the time complexity. Okay, so first we are sorting the pizzas, so that would cost us O of n log n as a time complexity. Okay, so this all would be constant time operations, and this would be O of n because let's say for we have n pizzas, then we will have n by 4 days, and uh, for all n by 4 days, we will have n by 8 count as odd days, and we will have n by 8 count as even days. So this for loop, we will run it for n by 8 times. Again, this for loop, we will also run it for n by 8 times. That would be similar to O of n only. So this would be O of n by 8, but that equals to O of n. So this two operation would be O of n, but for final time complexity, you can say O of n plus O of n log n. This was for sorting all the pizzas. So overall, it would be O of n on n log n only. For the space complexity, it would be O of 1 because we are not using any space here. We don't have any variables, such that list or something like that. So space complexity would be constant here. So this is our final code. I hope it's clear now. So let me know if you have any doubts in the comments. That's it for today. Thank you guys. Catch you guys in the next one. Peace.